300 million. That's the number of planets in our galaxy us alone capable of harboring life as we know it. And we have contacted none of them. 2025, this year. Not in a science fiction novel. The James Webb Space Telescope had detected something in the atmosphere of a distant exoplanet. A molecule. A molecule that, on Earth, is produced by only one thing: life. Scientists still don't know if that's what it is. But they don't know it isn't either, and that is exactly the problem. Tonight, I'm going to tell you about a planet. Not the one where JWST detected that molecule. A planet that is even more unsettling. A planet scientists consider more habitable than Earth. A planet where something may have a 3 billion year head start on us. And by the end of this video, you'll understand why the silence of the universe may not be a blessing, but a warning. In this video, I'm going to show you 3 things. Why Kepler 442b is not just another exoplanet, but an anomaly that challenges our place in the universe. Why the Fermi Paradox is more unsettling in 2025 than it has ever been. And a theory, taken seriously by SETI researchers, that if true, changes the meaning of everything we've been broadcasting into space. Fair warning. Some of what I'm about to tell you, I wish I had never learned. January 6, 2015. NASA's Kepler mission flags something unusual, 100 light-years away. In the constellation Lyra, they call it Kepler 442b. Here's what the astronomers measured: 0.836. Its score on the Earth Similarity Index. Earth scores 0.829. Kepler 442b scores higher. This isn't science fiction. It's a measurement published in the Astrophysical Journal. 30 billion years. That's how long its star will keep burning. A K-type star, smaller, calmer, 3 times more stable than our sun. No catastrophic solar flares, no scorched planets. It just waits, patiently. Our sun has roughly 5 billion years left. Kepler 442 has barely gotten started. But here's the detail that stopped me cold. This planet almost didn't exist, not in its current form. Around K-type stars there is a death zone, an orbital corridor where the star's gravity locks a planet's rotation permanently. On one side, eternal fire. On the other, absolute cold. Kepler 442b escaped that trap by just 47 million kilometers. Less than a third of the Earth-Sun distance. On the scale of the cosmos, a hair's width. But that hair changed everything. This planet still rotates. Day exists, night exists, heat circulates. And the conditions for liquid water on its surface are met. Now, the James Webb Space Telescope. Since its launch in 2021, it has transformed the way we search for life. It doesn't photograph planets. It analyzes their light. When an exoplanet passes in front of its star, a tiny fraction of that light filters through its atmosphere. JWST breaks that signal down into a spectrum. And in that spectrum, you can read the chemical fingerprints of the gases present. In 2025, a team from the University of Cambridge announced something staggering. On an exoplanet 124 light-years away, K218b was detected traces of a molecule called dimethyl sulfide, DMS. On Earth, this molecule only exists because marine organisms produce it. Algae, phytoplankton, life. The detection has not yet reached the threshold of absolute scientific certainty. And since then, other teams have reviewed the data and raised doubts. It may be nothing, but it is the first time a telescope has pointed at another planet and found something we could not explain without invoking the word life. So why am I telling you about K218b in a video about Kepler 442b? Because K218b JWST can observe. It is 124 light-years away. Kepler 442b is 200 light-years away, 10 times farther. No human instrument currently in service can analyze its atmosphere. We know it's there, we know it's ideal, and we stare in its direction, blind, like pressing your ear against a dark room, knowing something might be inside, without ever being able to turn on the light. Now let's do a calculation nobody runs at official scientific conferences, because its implications are too staggering. 3 billion years ago on Earth, there was nothing but single-celled algae, no fish, no dinosaurs, no you. If life emerged on Kepler 442b at the same time as on Earth, something there has a 3 billion year head start on us. An intelligence that advanced would look at our species the way we look at bacteria. Not with contempt, with total incomprehension. It's like asking an ant to understand what the internet is. Not a question of intelligence, a question of category. And yet, despite 300 million habitable planets, despite billions of years for life to evolve, despite civilizations that could have crossed the Milky Way dozens of times over, the sky is silent. Completely, absolutely silent. Los Alamos, 1950. Enrico Fermi puts down his fork and says, "But where is everybody?" 4 words. 75 years later, they still haunt cosmology. The most conservative estimates still yield thousands of potentially active civilizations in the Milky Way. Right now. And yet, silence. Here is what is new. In 2020, a team of astronomers published a study in the Astrophysical Journal on the speed at which an advanced civilization could colonize the Milky Way. Their conclusion: with modest technology, no faster than light travel, just self-replicating automated probes, a single civilization could cover the entirety of our galaxy in 1 to 2 billion years. The universe is 13.8 billion years old. There was plenty of time, several times over. So where are they? This is no longer just a philosophical paradox. It is a physical constraint. Either intelligent life is extraordinarily rare, far rarer than we can imagine, or it exists, and something is preventing it from speaking. One answer is the Great Filter, an obstacle so difficult to overcome that almost no civilization survives it. The question that should keep you awake: is that filter behind us or in front of us? If what destroys civilizations is precisely what they do once they become advanced: nuclear war, uncontrolled climate change, misaligned AI, catastrophic bioengineering, then the silence of the universe isn't a mystery, it's a graveyard, and we don't yet know which side of the filter we're on. In 2008, Chinese author Liu Cixin gave a name to what certain researchers had only ever dared whisper: the dark forest theory. The universe is a forest. Every civilization is an armed hunter moving silently through the dark. Rule number 1. Never reveal your position. A detected presence is a potential threat. A potential threat gets eliminated before it can grow. Since 1974, we have been broadcasting radio signals into space. We engraved our coordinates onto the Voyager probes. Our signals have already traveled 120 light-years in every direction. Not Kepler 442b. Not yet. But within that 120 light-year radius, according to the confirmed Exoplanet catalog, several thousand stars, and among them, dozens of planets in habitable zones. Planets that have been receiving our radio transmissions for decades. Our first television broadcasts, our military signals, our radar. There is something strange in that thought. The first human transmissions to leave Earth at the speed of light. The first to travel far enough to reach other stars were our transmissions from the Second World War. Our first words to the universe were war cries. If something is listening, what did it hear first? Kepler 442b is 1/200 light-years away. We still have time. Not much, but time. And if something out there is already watching us, the answer won't come from Kepler 442b. It could come from much, much closer. Tonight, beneath an orange sun 200 light-years from here. If something has been evolving for 3 billion years, it doesn't know. It has no idea that a small, curious species lost in a quiet suburb of the Milky Way has just pointed its telescopes in its direction. And now, the question is no longer, are we alone? The real question, the one that should keep you awake tonight, is who else is out there? And how long have they been watching us? Tell me in the comments. Does the silence of the universe comfort you or terrify you? In a next video, the Great Filter, the hypothesis that something systematically destroys every civilization before it can spread, and why some scientists think we may be approaching it right now, not after, before. Thanks for watching. Subscribe if you want more.